Is my blue light on? All right, good. So it's Algebra 1, Lesson 8.4, Translating Functions. And you need to be careful. Again, these last 3 lessons, you've got notes for them, but you're going to have to review if you're going to remember this stuff. All right, so let's start off with translating functions. What's a translation? It's the moving of a function to another location in the Cartesian plane. It's the moving of a function, and the object, the function, is not changed in any way. It's simply moved. It's relocated. It's a relocation project. That's what translation is. We're relocating it to another location. So the object is not changed in any way in a straight translation. All right? So that's the concept and that's the idea. I apologize for number 3. You guys are first edition notes, so sometimes we get some errors there, and I put a 3 there instead of a 2, so sorry about that. All right. We've already learned how to translate absolute value functions. We've talked about this before with absolute value functions. Does anybody remember? Maybe not. But again, you know, it's my responsibility as a teacher to teach you. It's your responsibility as a student to review sufficiently to remember. And you have to do that. And I dare say probably a lot of you don't remember. Well, the good thing is we're going to review it right now, and then we're going to apply these concepts with the new things that we're dealing with today. So on the left there, we have an absolute value function, a real simple one. You don't need to do this. I'm just trying to focus your thoughts, right? We have a y equals the absolute value of x. So let's go ahead and finish the xy chart there. So remember, we're going to put in the x value for x and solve for y. So when you put in a 0, what's the absolute value of 0? Say it if you know it. 0. Okay, and that's the point right there. Again, you don't need to do anything with that point. It's already on your graph, right? Then when we do a 1, what's the absolute value of 1? What's the absolute value of 1? 1. Absolute value is the distance the number is away from 0. The absolute value of 1 is 1. And you get this point right here. Again, you don't need to do anything. It's already graphed for you. I'm just showing you how we got the graph. What's the absolute value of 2? 2. So now we should have a point at 2, 2, and sure enough, it's that point right there, right? I did 3 as well. The absolute value of 3 is 3, and you can see it's that point right there. But here's the thing, and you guys had this probably a short answer question on your last test. The graph of an absolute value function is a blank shape, and you were supposed to respond it's a V shape. So again, if you only do that part, you only have a line right now. But you know it's an absolute value. You've learned it's a V shape, so you say, hey, I got to get the other parts of the V. So you try a negative number. So what's the absolute value of negative 1? 1. And that's that point right there. And really, that would be enough to get the V shape. I did one more extra just for emphasis. But the absolute value of negative 2 is 2, and that's that point right there. Okay, so there's our V shape. And that's the basic function. Y equals the absolute value of x. Wesley. Just to show you guys that it's a V shape. I knew it was a V. I could have graphed this with just 3 points. The vertex point on one side, point on the other, because I know what I'm doing. But you guys probably would have done something like that. You'd have kept going probably 3 points along the line and say, oops, where's the other part of the V? Let me get something to try to give me the other part of the V. That's how you'd graph them in real life. All right, so here's the pattern. Look over here again. I'm just doing this for emphasis. You don't need to do it in your notes. There's the pattern that we learned. Y equals the absolute value of x minus h, quantity squared plus k. And we said the h and the k value are the key values. There's the h and there's the k. So let's go ahead and graph this function and see where we end up. Now be careful, because now when you put 0 in for the x, you have to finish the whole thing. So 0 minus 1 is negative 1. What's the absolute value of negative 1? What's 1 minus 2? Positive 1 minus 2 is Now, everybody needs to be thinking. Again, if you sit there as a bump on the log and you're not thinking, and then you go home and say, well, I don't know what we did, it's because you're not thinking. You got to be thinking. Okay, so now put a 1 in. So again, you're looking at the function. 1 minus 1 is 0, right? The absolute value of 0 is 0. 0 minus 2 is minus 2. All right, let's graph these 2 points. Let's go to our graph and graph 0, negative 1. Let's go to our graph and graph 1, negative 2. Now, what shape are we expecting? A V shape. Okay. Looks like I'm on the left-hand side of the V right now, doesn't it? So I'm doing another number. I'm going to keep going because it looks like I'm on this side of the V. So I'm going to keep going here. I'm going to try 2 now. So 2 minus 1 is 1. Think now. The absolute value of 1 is 1 minus 2 is. See, now some of you guys, you're just cruising. And again, you'll go home and say, Mom, I don't know what I'm doing. I don't understand, Mom, but you're not thinking through what's going on. And if you don't know what's going on, raise your hand, and you need to figure out what's going on. You need to ask questions if you don't know what's going on, because this is your issue. Okay? You need to think through, and I should have everybody responding with me. So again, you're putting a 2 in for this x. 2 minus 1 is 1. The absolute value of 1 is 1. 1 minus 2 is a negative 1. That's what we're doing. We're working off the function. So that was a what? Negative 1. So now we're at 2, negative 1. I don't know about you, but I see the V shape right now. And I really don't even need to do any more of those numbers because I know it's a straight line this way. And I know it's a straight line this way. And there's my V shape. So once you're done drawing that, I want you to look up here because here's the this is the key to what I just did. I'm going to trace, don't do this in your notes, I'm going to trace over this one, the base model. And I'm going to capture it if it's going to let me. Okay, let's try this. Okay, good. So you agree that's the base model, right? Right there, it's captured. Now look at the function. We learned this with absolute values. This is 1 right, and this is down 2. That's what we learned from the h and k. We learned the h was left right, and the k was up down. And so we learned this should be to the right 1 and down 2. Is not our new one the old one that went to the right 1 and down 2? Didn't we just simply move the shape 2 to the right and down 1? Again, I'll show it to you again. Here's the original. I'm going to go over to the right 1, and I'm going to go down 2, and there's my shape. Got it? You follow? And that's what we're doing. And look, math is orderly. This happens with absolute value. We're going to do parabolas today. It happens with parabolas. It happens with polynomial functions. We're going to do those today, cubics. It happens with circles, h and k. It happens with ellipses, h and k. It happens with, you don't even know what hyperbolas are. It happens with hyperbolas, h and k. Because math's nice and orderly. And they all get translated by the value of h and k. And that's a really key concept. And hopefully you can get it down through today's lesson. All right, so let's go on to this aspect. So let's write it. I just mentioned this. The amount of the translation is determined by the values of h and k. They tell you how much it's translated, h and k. Anybody know what goes in the first blank? H is the blank translation. Which way does h move it? Horizontally. So h is the horizontal translation. Horizontal. When you're going horizontally, which way is positive? Say it if you know it. Positive is to the right. Negative is to the left. Just like slopes, by the way. Positive x value is moving right. Negative x value is moving left. So therefore, K has to be the what translation? Say it if you know it. Vertical. Again, you guys need to be thinking. You need to be thinking. So therefore, positive K would do what? Go up. And negative would be down. Okay, that goes right along with our slopes. The only difference is, remember, our slopes was the vertical was the top, horizontal was the bottom. Here, the vertical is the H, the first one you get to. The horizontal is the H, the vertical is the K. All right, so let's deal with the quadratic pattern. So there's the quadratic pattern. Why is it quadratic? It's this squared right there that makes it what we call quadratic. Notice there's an H and there's a K. Now, notice this looks just like the absolute value. Look up at the screen. Don't do this in your notes. The absolute value would have an absolute value there and would not have the 2. Otherwise, there's the absolute value pattern, right? So the difference is it's got a parentheses instead of absolute value, and it's got a squared. Other than that, it's exactly the same as the absolute value, and it works the same. So in this, the coordinates of the vertex, and I'll show you what that is in a moment when we get to the next page. But the coordinates of the vertex are HK. By the way, this was the same with the absolute value. Look back up to the second example here on the right. The vertex of our absolute value, isn't it at 1, negative 2? Isn't that right there, 1, negative 2? By the way, the original to the left, if we wanted to write it fully out, we could write it like this. The absolute value of x minus 0 plus 0. Isn't the vertex of the first one at 0, 0? But we don't bother writing zeros, do we? We don't. So HK is the key. It gives you the vertex, and that's a key point. All right, so let's do a couple. We need to name the vertex and describe the translation. All right, so I need you to think. So I'm going to ask you a question. You need to say it out loud. What do you think is the value of H? Say it if you know it. It's positive 2. Again, the negative is black. I know this is weird, but you read the value after a negative sign. That's why I used the color, and I used it specifically on purpose. So you read what comes after the negative, and it's a 2. All right, this is a little bit more abstract, so all of you may not know the answer, but if you do, say it. What's the value of K? 0, not 1. If it were a 1, we'd write a 1. There's nothing there. Nothing is a 0. So remember, the H does what? Left, right, or up, down? What does the H do? Left, right. So what is a positive 2? Say it if you know it. 2 right or right 2? 2 right or right 2? Don't bother saying doesn't move up or down any. All right, how is this moved? 2 to the right. This is a quadratic that's moved 2 to the right. 2 to the right. Let's do the next one. I'm going to get rid of my screen here so I can put this higher. So let's move 2 to the right. All right, so look at number 2. What's the H value of 2? Say it if you know it. What's the H value of number 2? 9. What's the K value? 0. So how would this be translated? Say it if you know it. 9 right or right 9. Either way is fine with me. You can put the number first and then direction, or direction first and then the number. All right, now look at 3. We went through this with absolute value, but I want to refresh your memory. In number 3, we have a plus sign where the negative is supposed to be, don't we? Because this is a simplified form. You're not ready to really read H unless you remember that H is what comes after the negative sign. Isn't negative a negative 3 a positive? So really, what is the value of h? Negative 3. And again, our k is 0. So how is this one translated? Left 3. Left 3. Some students just say, okay, it's always the opposite for the h value. If I see a negative in front, it's positive. If I see a positive in front, it's negative. And they just try to remember it that way. But that's really why. That's what's going on. The negative's part of the original form, and you read after the negative. All right, let's go to the second page. Any questions so far? Remember, we're moving them, Gabby. The exponent is what's going to give it its shape, and you're going to see the shape here on the next page. The absolute value, Gabby, is what gives this the shape, and that's why we learned absolute values are V shape. The square, the 2, gives it its shape, and so that's this page 2, and the shape is called a parabola. You see that U shape? It's called a parabola. Now, those on the video aren't going to be able to see this, but parabolas happen naturally in nature. Ethan, I know you're a good catcher. I want you to look at the shape. Now, that's a U shape up. Parabolas also have a U shape down. Watch the shape of the ball. It's that U shape upside down. Ethan, throw it back. Give me a little loop, right? So the more I loop it, sorry about that, bad throw. Can you grab that for me? But I was trying to show the U shape. The more I go up and down, did it come back to you? Cool. So again, if you watch, see that U shape? See that? It's a perfect parabola, it's called. This is a squared function. It's a perfect parabola. You know when the artillery shoots down there at Quantico, you know what they're shooting? Parabolas. You know what they're calculating into their distance and rangefinder? Parabolas. Comets. Some comets have parabolic orbits. Some of the craft that we sent had parabolic orbits. You remember when that one Apollo mission was in trouble and they had a slingshot around the moon to come back to Earth? They used a parabolic orbit to do that. So there's parabolas everywhere. But anyhow, Gabby, that squared makes it a parabola. And if you'll notice, the same principle applies. Look on the left. H and K are 0. Where's the vertex? At 0, 0. What should happen on the one to the right? We should go right 2, and we should go down 1. Do you agree? And look what happened to the original parabola. It went right 2, and it went down 1. Now, you guys aren't going to do a lot of graphing of them. We'll do a ton of graphing of quadratics in Algebra 2. But you guys are learning the principle of translation, the principle of translation, the moving of a function due to the h and k values. So now we're just going to apply what we learned to parabolas. So name the vertex and describe the translation. All right, this first one, we have nothing in there. So the h is a 0 plus 2. So what's h? 0. What's k? 2. Now, normally you wouldn't have that gap in there for the 0, but I just want to refresh your memory or show you that the h could be a 0 just like some of the k's were a 0 earlier, right? So how would this thing be translated? Say it if you know it. Up 2 or 2 up, right? Up 2 or 2 up. There's no left or right. The h is 0. The horizontal is 0. The vertical is up 2. Positive is up. Negative is down. Now, the second one is normally the way it'll look with the parentheses when the h is a 0. We'll just say, really, x squared, and usually it won't even be a parentheses there. It'll just be x squared minus 7. I'm just trying to keep it clear for you guys. But again, normally this would just be, oops, I want it black there. Normally it would just be x squared minus 7. And so the h value is 0, and the k value is negative 7. The K is exactly what it says with the sign. There's no difference in the K. It's only the H that you read after the negative. So we know it's not moving left or right. So it's up 7 or down 7? Down 7. And we're translating, we're moving this parabola down 7. All right, the third one has both. I want you to fill in the value of the vertex, and I want you to say which way it's translated. So everybody doing that. Fill in the value of the vertex, the H and the K value, and then say how this is translated. Do the H first, do the K second. Fill in the HK. Determine the value of the translation. Who wants to give me H and K? Quinn, what's H and K? How many agree with Quinn 1, negative 2? Okay, you'd be all the correct ones. It's 1, negative 2. Who wants to give me the translation? Zach? Write 1. I wouldn't write anything yet. Let me finish and then see if you agree. And down 2. How many agree with that? Write 1 and down 2. And that would be correct. That's correct assessment. All right, there's one with no color, but now we've done color. But be careful. Color, look at my numbers. Wow, first editions. Man, I'll tell you, must have been auto numbering or something. Who knows? Hate auto. You ever get auto correct and it corrects things that you don't want it to correct? Drives you nuts. Must have been auto numbering or something. I don't know how I got those numbers, but anyhow, do the fourth one there. Give the value of the vertex. There's no color now, and there's, gotta be careful. Give the value of the vertex and then give the translation. Value of the vertex and give the translation. Who wants to go for the value of the vertex? Sam, what do you got? How many agree with Sam? It is negative 3/8. And you're all correct. See, Sam recognized that plus sign there and knew it must be minus a minus 3, right? All right, so who can give me the translation? Wesley? Left 3 and up 8. How many agree with left 3 and up 8? And you'd all be correct. First number's left or right, positive is right, negative is left. Second number's up and down, positive is up, negative is down. Questions on that? Questions on that? Questions on that? Anybody? Questions? 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 I feel like I have a dog collar on, but it's better than wearing it because it closes one ear and then it feels funny. I'm trying to get away from it because I pop when I'm right in front of the microphone. So anyhow, no questions on that? Got that? Okay, let's go on to the next thing. Here, I'm going to get rid of the shade because I need to move this up. So the next thing is to write the equation. We've done this before, writing equations with linear things, right? And our pattern was y equals mx plus b. Do you remember that? And to write the equation of a line, you need to know m and b, the slope and the y-intercept. Well, here we have a pattern as well. So you need to use the pattern, and instead of filling in the m and the b, the slope and the y-intercept, you have to fill in the h and the k. You got to fill in the h and the k. So it'll be a question like number 1. Write the equation of the quadratic if it's translated 3 right and 4 down. So somebody tell me, what would the h value be if it's 3 right? All right, let me call on you. Ethan, what do you think the h value would be if it's 3 right? Okay, positive or negative? Positive, and I agree, positive 3. Beilul, if it's down 4, what would the k be? Positive 4 just like that? Okay, that one is, down is negative, so that one's a negative 4. Up is positive, down is negative. Right is positive, left is negative. Hey, all you do from here is fill in the h and the k. What is h? 3. What is k? Negative 4. Voila. That's not hard. You do have to know the pattern, though. But remember, our pattern is real close to the absolute value pattern, except a parentheses where the absolute value is and the parentheses squared. Other than that, it's the exact same pattern. Number 2, write the equation of the quadratic if the vertex is 4, 1. Value of h. Atanel, what's the value of h? 4. Dave, what's the value of k? 1. So this time, instead of telling us how it was moved, they gave us the vertex. So we know that this is moved to the right 4 and up 1. But we're ready to write h and k. Remember, the vertex has values of hk. So again, we're going to do our pattern. Y equals parentheses x minus h quantity squared plus k. And every time you write it, it helps you to remember it. I would write it tonight each time. It's going to help you to remember. That only took about 3 seconds. And now I'm going to put in h and k. Y equals parentheses x minus 4 quantity squared plus 1. There's my equation. All right, go ahead and do the third one. Because you need to know hk, I put off to the side h equals, k equals. Write your pattern, fill it in, and voila. And then you should simplify it. So have your final answer in simplified form. Put your final answer in simplified form. So did you say x squared plus 2? Because again, an x minus 0 quantity squared, we'll just put that in a better form. That's true, and that's correct, but the simplified form is just x squared, right? When the h is 0. Questions so far? Questions on quadratics? Questions on quadratics? Now look, if you're in the dark, you need to ask now. I just spent 15 minutes building up and trying to lead your thinking and trying to bring in things that will help you to understand. And if you don't understand, the best time to get it cleared up is right now. And the best time to ask is right now. So let me try one more time. Any questions, anybody? So I have to assume as a teacher, everybody's clear. All right, last page. So now we have a cubic pattern. Notice how similar the cubic pattern is. Do you see the only difference? Do you see the only difference in the cubic pattern? It's just the exponent, right? That's the only difference. This exponent's cubed. It's the only difference. Instead of squared, it's cubed. These have a different shape. These don't have a vertex. They have what's called a point of inflection. Point of inflection. I'll show you what it is in a minute. But the coordinates of the point of inflection are hk. Cool. And the hk, just like always, tells you the translation. And look, if we were doing a circle, it'd have h and k. And you'd know how it's translated by h and k. I wish I had time. I'd show you a circle. I'd show you an ellipse and the h and k in the ellipse. I'd show you a hyperbola and the h and k in the hyperbola. And they all move the exact same way. All the same way. All right, so here's the base model. Don't need to do that. I'm doing that for emphasis for you. Of a cubic. Notice how it like mirror images about this point of inflection. It kind of changes direction or kind of changes its shape there. These can go in a lot of different ways, but this is the base model. And notice the h is 0 and the k is 0. So watch, I'm going to do this again. I'm going to trace over this. All right, let me see if I can catch it. Oops, come on. Give me just, no. All right, let me do it this way. Got it. All right, according to this, should it be left or right, up or down? Left 2. That's the H value. And the -1 says it does what? Down 1. Again, you got to be thinking. All right, here's that copy, right? I got to write in the point of inflection. It's too late. So again, it would be right here. I have to take it to the right 2, left 2. I'm sorry, not right, left 2, right? I'm here. Left 2 and down 1, and there it is, all right? It's the exact same curve moved 2 to the left and down 1. Move 2 to the left and down 1. Same thing we did with the parabola, same thing with the cubic. So same situation. Name the point of inflection and describe the translation. Remember, the point of inflection is HK. So we've done this 3 times. Can somebody tell me the value of H? Just say it if you know it. 2. Somebody say the value of K. Say it if you know it. 0. So if you know the translation, say it. Right 2. Remember, the first is always right, left. The second is always up, down. Because the first is always the X, right? Isn't X left, right? Isn't the second coordinate always the Y? Isn't Y up, down? I mean, math is orderly. Math goes in order. Okay, second one. Again, I don't know why I put that parentheses there. It should just be x squared minus 11. What's the value of H? Say it if you know it. 0. What's the value of K? All right, ready? Describe the translation. Down 11, right? Down 11. Uh-oh, no color. Now, surely we don't know what to do. Hey, at least I got my numbers right this time. Say the value of H if you know it. -1. Value of K if you know it. 5. See, the same people are the ones saying things. They'll be the ones that will remember tonight. So tell me the translation. Left 1 and up 5. Left 1 and up 5. All right. Again, the first is the X coordinate. Left or right. Positive's right. Negative's left. Second is the Y coordinate. Up is positive. Down is negative. Uh-oh. Write the equation of the cubic. We'd have no idea how to do this, would we? This would be impossible. We'd say, oh, I don't know how to do that. It's an impossible question. I don't know how to write the equation of the cubic. What would you start with? What would you start with? The pattern. I would start with a pattern. Pattern's easy. It's just like absolute value, but there's a parentheses instead. And it's a cubic, so it's cubed. And again, every time I write, it helps me to remember it. And look, if I get it down, I should be able to do absolute value, quadratic, and cubic because they're so similar. They are so close to each other. I should be able to learn the pattern very easily for all 3. So what is the 5 here in the point of inflection? The 5 corresponds to what? H. And the 9/2 is? Stick it in, man. That's it. Just put it in. X minus 5 quantity squared. Don't forget your square up. Cubed. Whoops. Cubic, right? Hey, by the way, how would I know this was a cube if they didn't tell me? Eva? Well, no, they don't show us any exponents. So how would I know this is a cubic if they didn't show me? Adam? It says point of inflection, and cubics only have point of inflections. All right, so yeah, if they didn't tell us, that's how we'd know. And then we got to add the K, right? Plus 9/5. We'll just leave it as a fraction. Or 9/2, I'm sorry. No Kool-Aid for you, Kyle. 9/2, right? Translation, look, I started the whole lesson with this. I know this is stuff that's, it takes review. And it's going to take you guys reviewing this stuff to remember it come quiz time and test time. Hopefully you're good for the homework tonight, but you got to remember past that. So be careful. You need to go back and review. All right, your homework's listed at the bottom. 1 through 6, 11 to 14, 18, 28, 32, 34, 45, 47. Some are very quick, like we did, and you're saying right 2 and down 4, stuff like that. Wesley. The quick answer is I don't remember. So I'm not sure.